Hello friends, welcome to my YouTube channel. We are having topics on this YouTube channel from the HVAC, from the project management and from the motivation. I request everyone to give your valuable comments, your motivation so that I can go on improving myself. I hope you are liking the videos. The ones who are not subscribed my channel, I request you to subscribe my channel and get a lot of benefits. Spread it to your friends. I'm sure you will get lot of insights. Let us look at today's topic. Today's topic is the V from HVAC. The V for ventilation. V is very important in HVAC. It is not the only air conditioning which plays an important role, and ventilation also is very significant in our projects, in our life. Let us look at some aspects of it which can give you a little more clarity on this topic. The ventilation is generally done to see the pressure balancing, right? See, areas which we are supposed to ventilate it, there is a natural ventilation. We have a window on the other side. The next day, the next volume, another window, wind comes, it goes out. It's a natural ventilation, and you don't have to work on the pressure. But there are some requirements, there are some processes which needs a pressure balancing. So if you look at here, there is always a positive and negative pressure. How do you balance it? One case over here where you have a extract or exhaust which is more and you are maintaining a negative pressure. What you do is you take less pressure and more exhaust. Here you can see the pressure comes here, exhaust is more than the pressure, you maintain negative pressure. When you have pressure more and exhaust less, which is here, this is supply ventilation, and then we maintain a positive pressure, right? And then we have balanced ventilation, like I said, right? You have same amount of pressure coming in, same amount of exhaust happening, where EA is equal to FA, you get a balanced ventilation. So this is a fundamental principle for different applications of ventilations. Let's look at one of the important applications. This is related to our life safety. This is a staircase pressurization, right? When the fire happens on this floor in the building, then you must evacuate the human beings from there through staircase. If the staircase is outside of the building where you can get natural fresh air, you may not require a forced ventilation. We have the windows over here or grills over here which can bring in that pressure, and this entire stairwell can get pressurized. But there are buildings where the staircases are internal. Even some cases, some customers, they put an extra effort or extra addition of having a forced ventilation, where what we do is we have forced ventilation fan, pressure fan, which is the top of the staircase. In case of fire, this stairwell is pressurized with air so that the fire from this don't get into the stairwell. In Indian context, we maintain 50 Pascal pressure difference between the zone which is under fire and the stairwell. So what happens is when the people come out to get escaped from this building, they should have a clear space. There should not be any smoke coming out from here or fire coming out from here. That can have huge impact on the people who are into the staircase. So you want staircase to be clean, clear, free and pressurized, so that people can easily get evacuated from this building. This is the reason why we put staircase ventilation fans, right? It is related to life safety, very important. We also pressurize when we have lifts in the building, your passenger lifts, your fire lifts. We also need to ensure the lift don't get fire inside. So lift lobby, the lift well gets pressurized by again a fan which maintains the positive pressure here. This fire zone, the fire don't get into the lift lobby. Again, I talked about stairwell pressurize. This will help the fire doesn't spread to the lifts, also to these stairwells, also to the lift lobbies. So how do we get human beings evacuated safely? is very, very important in case of fire. There are other applications like kitchen exhaust, toilet exhaust, basement car park. Again, that is also related to a fire as well as general ventilation. We have factories, we have chemical industries, pharma industries. These industries, they will have different types of exhaust to be done because we will have chemicals, right? How do we take them out safely into the atmosphere is again a challenge. So these are some of the applications. Let's go one by one. Kitchen ventilation. In a small kitchen, you have a chimney over here which collects the smoke and takes out with a small fan the smoke of the kitchen, and then your kitchen is clear, right? When you have multiple or big industrial kitchens, you have many kitchens working in a building, you can have common fan connect to the kitchen chimney that can extract the exhaust from the kitchen, right? When you have big ventilation fans required, if the capacity of the kitchen is huge, so that you exhaust it out the right amount of smoke so that your kitchen is clear. One application. The one important issue here is when we take out the smoke or the air from the kitchen, you also take out the oils. The oil can also travel along with the air. How do we segregate? How do we handle that oil is a very, very important aspect. So you should have the fans which has got a motor which is generally not in the air path, so that motor don't get impacted with the oil, presence of oil in the air, right? One of the way to do that. Next is toilet exhaust. You must have seen such fans. Again, when you have multiple toilets, when you have huge toilets, the fan size can increase. You can duct the multiple toilets and have one central fan on top which can evacuate the toilet exhaust, the foul air from toilet, right? Only a disadvantage there is if you have one fan handling multiple toilets, if the fan has issue, your toilet exhaust stops. Next is car park. And again, this is related to the cars being parked. When they come in, they have exhaust which has got CO, right? So we have to remove the CO, which is when the car comes in, the exhaust, that's one area of exhaust or ventilation. For that, we need to have fresher, we need to have exhaust, and if the car park is huge, you need to displace that air from fresher side till the exhaust point, and for that we generally do a ducting. But the new technology or the modern technology use these jet fans, the displacement type jet fans, which can take the air from here, go to this fan, it will shift it to another fan, and then we have exhaust fan somewhere over here which finally takes the CO out, right? But the same issue comes when we have fire in the basements. What happens in case of fire? All these fans are designed such a way that they go on higher speeds and you evacuate the smoke fast. Remember, people die because of smoke than the fire. So very important to remove the smoke from the zones. If you have huge basement is divided into multiple zones. According to zones, you make your systems zone by zone, right? Rather than having one fan for the entire basement and spreading entire smoke everywhere. So you have a proper scheme developed, and the scheme has to be tested, commissioned, so that the result or the purpose for which it was designed is seen on the ground. You need to do the testing. So these are the basement car park ventilation fans. Now let us look at what is required for effective ventilation. One important thing is air changes per hour. Now there are a lot of standards available for which type of application, how many air changes are required. This should be optimum because we can't have higher air CPH just for sake of it. The fan size will go up, the motor size will go up, your power requirement will go up, space requirement will go up. So you need to balance that. That's why I'm talking about optimum. Supplied air must be fresh, free from dust. So you need to add filtration. And if the area is very, very sensitive, you need to look at what kind of filtration. When you work in refineries where the outside air is polluted, you may have to get for carbon filter so that you get the right pressure inside. Try to keep pressure inlet at lower end and exhaust at higher. It's a very simple thing. The pressure generally heavy. When it comes inside, if you have pressure, the route of the pressure or the flow of the pressure, the path of the pressure and exhaust, if it is lower, it goes up and it gets exhausted. That's the effective way of doing ventilation. Is humidity a requirement? They need to be very, very cautious about what pressure. Are you getting raw pressure outside where the humidity is high outside, or you need to treat and get the right amount of humidity if the humidity is a requirement. Consider also outside temperature, right? When you have, if you have temperature requirement inside and you want to bring the raw outside pressure which is already warm, it will not give you the desired result. So you need to be very clear about what are the requirements, right? So hope these points are clear. ACPH, filtration, the route of supply and exhaust, right? The humidity requirement and the temperature requirement needs to be very, very clear. Now, what are the steps for ventilation systems? How to select a ventilation system? Understand the process. First important process. It is not generally the only general ventilation, right? Find out the required ACPH. Find out then what is the air quantity, right? Route for ducting is important. Otherwise, we'll find put a duct and then you don't have height. Doesn't happen, right? Or doesn't work out like that. Calculate static pressure. If you are going to select a fan and the fan has to draw air from one side of the corner of the building and throw it long, if there is a ducting involved, it will have resistance. So that resistance is basically an external static pressure. So you need to calculate so that you select the fan with a capacity that can pull that air from that area, right? Select a suitable fan. There are different types of fans. We are going to see it. You need to select a right fan, right? When it comes to smoke or fire, the fan has to be rated for that fire, for that temperature. You can't just select this normal fan. The fan will get melted and you will have trouble. Let us look at this ACPH table. From where we should get ACPH? So these are some of the areas or applications. These are some of the standard ACPH given here, right? You can refer this table and go for it. How do I calculate air quantity? Obviously, it is volume of the area multiplied by ACPH. When I talk about hour here, then I have to divide by 60 so that I get CFM. Hope it is clear. Volume of the room, which is cubic feet, into ACPH divided by 60 to get air quantity in CFM. You need to design a route, a proper ducting. You should see that the ducting doesn't have too many bends, otherwise it will act more resistance. Your fan capacity will go up. Look at the proper layout. See a proper smooth route. How do you select a fan? A fan is basically, when we talk about CFM, right? CFM is volume into ACPH into 60. That's one aspect. We have to see what is the static pressure, right? We have to see what is the application. So these are two important things: the air quantity, static, and the application. Based on that, fan can be selected. Now, various types of fans: the centrifugal fans, the axial fans, we have mixed flow fans, we have jet fans. Within centrifugal fans, we have forward curve, we have backward curve, we have radial. Axial fan, we have propeller fan, we have Van axial fans, tube axial fans. The various fans and the requirement depends on your applications. So, if you talk about fan blades, these are the various blades where we have constant thickness blade, when the blade thickness remains same. We have aerofoil. It actually helps you to reduce the resistance. You say aerofoil design, so the resistance becomes less. Then we have curved blade fans, different types of blades. Let us look at fan efficiency, right? Also, we need to look at when the fan runs, if they are running continuously for certain application, we need to look at the power consumption. That actually depends on the efficiency of the fan. So if you look at various types of fan over here and the peak efficiency range, you need to select the highest or the right efficiency for this. And you can see the efficiency ranges different for different type of fans. See this table, I think you will get the right idea. Let us look at the fans. Now, axial fans. This is like a aeroplane propeller, right? These are called axial fans. The blade creates aerodynamic lift, air is pressurized, then air move along the fans. This is how they work. They're very popular in industry, were compact. You can see our toilet exhaust fans, small fans. They're low cost, they're lightweight. The issue there with this is the noise, right? Applications for this fans are normal ventilation, your exhaust. It can be for ducted exhaust, smoke, steam. But when you talk about smoke and steam, you need to look at the fire rating of these fans. They have to be certified or rated for that application, right? When you talk about actual propeller fans, this is the high airflow at low pressure, because single fan you don't have to put a lot of resistance, otherwise it will not deliver that kind of air quantity. So these are free flow fans, very little duct or no duct, inexpensive, suited for rooftop or side flow, right? Disadvantages, I said, noisy, and they are less efficient. Let us look at the next fan, which is type of axial fan, which is tube axial fan. This can encounter higher pressure, right, for a duct which is connected to it, or there is a lot of resistance in the system. Medium pressured, high airflow fans, quick acceleration. It occupies less space because it is axial. Disadvantage, again, energy efficiency, right? Expensive and noisy. Axial fans are generally noisy. Vane axial fans, these are suited for medium and high pressure. You can see the vanes over here. You see vanes over here, and you can see vanes over here. They are suited for medium and high pressure fans. Again, quick acceleration. Because of the vane blades, they are energy efficient, right? Because they can handle more air and more pressure less. Why? Having less power consumption. The disadvantage of this fan is they are expensive. Let us look at centrifugal fans. They are belt driven, they are direct driven, they are forward curved, or they are backward curved. Now, forward curved generally we use in fan coil units. You can see a forward curve fan over here first. Second, you can see the backward curve fan. You can see the curve of the blade, and we can see a radial. You can see the difference from these pictures. So forward curve generally go for FCUs. They're constant or curved blade shape. They're medium efficiency, right? Backward curves, higher efficiency. They can handle little more pressure, right? And radial, they got straight blades. They've got straight blades, right? Let us look at jet fans. These are basically displacement type of fans. They're axial jet fans. You can see they're induced jet fans, but the induction happens from over here and exhaust is here. In this case, the induction is here and exhaust on the other side, right? There are inline inducted fans where you have small duct connected to it. They are fitted inside the ducts, or along with the ducts. You get a lot of rooftop fans. You get wall mounted fans. Various applications based on your site, based on your design. You can put it either on wall, you can put in duct, you can put on roof. Fan and life safety, I spoke. Generally, we get a fire rated fans for such application. Otherwise, the fan will not work in case of fire. So they have to be rated. They have to be tested by certain agencies. Tunnel ventilation is another important aspect. In India, a lot of tunnels are being built. Metro tunnels are being built. How do we do circulation? This fan can't work. So they have to have special type of fans like this. So they displace air from one side of tunnel to another side of the tunnel easily, effectively. Otherwise, we'll have suffocation inside the tunnel. So tunnel ventilation is becoming big business in India, because you can find everywhere either tunnels are getting created, metros are getting created which are underground. Car park ventilation, I said this is the fan, and you can see the car park. These fans get activated by a CO sensor. When the CO comes in, this fan goes in double speed. When the fire goes in, they get a fire signal. They go in double speed. Otherwise, they maintain general ACPH as per the local building code. How many ACPH they have to be maintained in the car park. This is how they work. You can see the pressure comes in. These fans are displacement type fans. They take it one end, go other side, and finally it gets exhausted out. So they are actually designed for dual speed, or they are controlled by VFD, so that they can adjust the speed of the fan so that air quantity can be increased or decreased. Design consideration, we can see design coordination, we can see the right design, wrong design. Why? Because if we have a exhaust and entry in one line, there will be short circuit. The ventilation in this zone won't happen. If we have like this, the entire space can be ventilated properly. Hope this is clear. You can't have jet fan and there is an obstruction in front of it. The fan will not be able to displace the air from here to the next fan because there is an obstruction here. So you can see, you can take the fan little away. Here it is a total obstruction very near to this beam. This can have impact on the performance of the fan. This is the right way of putting the fan if you have obstruction in front of it. Don't put the fan directly in front of any obstruction on the wall. So hope you got clarity on ventilation. Some of the points, brushing of your knowledge. Thank you so much. Please subscribe my channel. Follow me on YouTube, Facebook, LinkedIn, ajazkazi.com. Thank you so much.